Hello there, I'm Jeremy Warren from NanoSight, and before I tell you about the new NanoSight NS300, let me run through the characterization technology that is nanoparticle tracking analysis. We detect and visualize nanoparticles in real time. Nanoparticles in liquid between 1 and 1,000 nanometers. A real-time image allows us to track the individual particles and measure their size using video tracking. If we can see the particles and measure them frame to frame, we can apply a diffusion coefficient calculation to each one, measure the sizes, and produce a particle size distribution that is truly high resolution. We also know the volume that we have here, and that allows us to produce a concentration measurement. So the interrogated volume we know, we measure the concentration. So we have a combination both of particle count and particle size distribution at a high resolution format. Now, in addition to that, if we apply an electric field to the NanoSight view, that gives us an opportunity to measure the surface charge or zeta potential of the particles. Once again, we're doing that particle by particle and high resolution, so we can begin to understand the zeta potential of particles with different zeta potentials within a mixture. Additionally, and this is really what I'm describing here, is simultaneous multi-parameter characterization. In addition to that, we can use fluorescent markers. Now, you don't need fluorescent labeling to use NanoSight, but if you have it, it's likely that we will have an excitation wavelength laser to be able to use your fluorescent labeling and the right filters to be able to eliminate the background. And you can then look at specific samples and only look at the target particles which you've labeled. So all of that multi-parameter characterization comes back to your ability to validate what you've seen by looking at it directly. Look at the NanoSight view and believe your eyes. So that's where NanoSight comes from. Now, we've been doing this for a while, but the NS300 is a significant step forward for us. This fits within our range of products between the microscope-based LM10 system and the NS500, which is a fully automated system with fluidics on board for more automated operation. What we tried here to do is, apart from a much smaller footprint, which obviously helps in busy laboratories, the main feature of this is that we have a spinning filter disc inside with up to 6 different fluorescent channels. Now, what we have here is the opportunity for a single laser excitation wavelength to illuminate perhaps quantum dots of a number of different wavelengths, quantum dots producing a number of different emission wavelengths, and simultaneously track several populations of particles according to their fluorescent signature. So we can differentiate, speciate, if you like, several different channels using one laser to illuminate them. Now, if we can actually, and there's a major challenge here, specifically for our users and the experts in fluorescence, if you can co-locate 2 different fluorescent markers, different ones, on the same particle, of course you've got an orthogonal measure of speciation, which is terrifically interesting. So that's the main features we have here. In addition, we've included in the software a rheology function. Now, if you can use NanoSight to measure particle size because you know the viscosity and you know the temperature, then if you dose particles of a known size into the system, of course you can recover the missing variable, which is viscosity. So that's nanorheometry. It's specifically applicable to low viscosity systems, 1 to 5 centipoise, and we see an application for that in hydrogels. So that's part of the software of NanoSight going forwards.